My name is Primoz Podrzaj. I come from the Faculty of Mechanical Engineering, University of Ljubljana. I will present the paper titled Applicability of Arduino Microcontroller with a LoRa shield-descent element in IoT. So I am the first author, but my co-authors are Tomaz Pozrl, Marjan, Jenko, Luka, Selak, Gasper, Skulj, Lidija, Rihar, Vrabic, Drago, Bracun, Tomaz, Berlec, and Dominik, Kozjek. So there are so many authors because actually this paper is just, how to say, a concept that we use for some other more complex tasks that we work in. So first I would say what IoT is. I guess you all know it. So it's Internet of Things, and it describes a concept in which devices are typically equipped with some kind of sensors and data processing capability, and which exchange information with other devices over some kind of network. So in this case, these devices are often called sensor nodes, and we will use them in a beekeeping application to measure various parameters. So this paper will be about temperature, but later I will tell what's our main goal that we are working on. So some IoT related challenges. So first of all, it depends on application. If you have a power supply nearby, of course, energy is not so much of a concern. But in our case, this is maybe the major part that we are interested in, so that the power consumption is not too high because the whole system is typically battery powered. And of course, you don't want to change batteries too often. The others are self-management, then unattended operation, also very important in our case, because what we measure has to be done 24/7 in some often remote area. So it should be reliable and autonomous. Then also, typically you need not typically, but sometimes you need a multi-hop communication because signal gets attenuated and you want to transfer information via the net. So of course for us, let's say security is not that much of concern, and also design constraint maybe not so much. So IoT network protocols are divided in three major groups. WAN, LAN, and PAN. So maybe the most familiar ones are LAN, local area networks, which typically have ranges, I would say, up to 100 meters. So what we need is wide area network because these devices are located far from where the data is in fact collected. And let's say you all know personal area networks, typically, let's say, credit cards that you used to pay. Of course, all of them have many protocols, and I would focus on the first group in this figure. There are actually three important things. First is the range of the solution we apply. The second is data rate, and the third one, not shown here, it's energy consumption. Typically, you cannot get all three of them. For example, data rates are the highest, as you see here, in local area networks. Short range and long range are both associated with lower data rates. let's say in our case, of course, you don't need temperature measurement in beekeeping like every second because it will not change so often. So for us, it can be done maybe every half an hour is enough, or at least like 10 minutes. We don't need more than that. Okay. So here is a comparison of suitable protocols for our applications. I would not go into all details. So our our choice was LoRa because it's very simple, has a very low cost. Battery life is really good, which is, I would say, these 10 years, it's more like theoretical value. But in any case, you see it's the highest number here in this table. And data rate, of course, it's not that big, but to be honest, this was maybe the thing we cared about the least. Okay, so our application was meant to be done in a way that later you will see that in beekeeping there are different possibilities. So in Slovenia, some other solutions would also be possible because the beehives are designed in, I would say, I don't know the reason, but throughout the world you seldom see this kind of solution. But for the one that is most common in other countries, you have beehives dispersed over some area, and typically you want to collect this information from sensor nodes on a hub, which is also one of the beehives, which then transfers all this information to let's say data collection that can be done in a computer, which is let's say quite far away. Okay, LoRa has different frequency bands throughout the world. So as you see, Slovenia, this is my country, is the last one. We are close to what the Germans have. Typically, it's the, let's say, the country that influences us most from the technological point of view. So other countries, of course, have different frequency bands and also different channel plans. So LoRa is a link layer protocol. So here you see the schematical representation. So to be honest, I don't need to go into too much detail here. Then think about power consumption. So in our case, this is a sum of two parts. First part is part when the device is active. That means that measures temperature and also transmits the data. And this is like very short period of time, but at that time the power consumption of course is by far the highest, but then the device is sleeping for the vast majority of time, as I already told you. So all to all, I would say the power consumption during the sleeping phase is the most important, so that it is as low as possible. So during the active phase, which is divided in like six subsections, so wake up, measurements by the sensor, data processing, then wake up of the radio module, transmission, and data reception. And of course, the phase marked by red color is the sleeping phase. So Now let's go to these beekeeping practices. So the one on the left is a beehive that's typically used in Slovenia. It's actually a beehive of a friend of mine. With it's like how to say, he's employed and even has a farm. So typically beekeeping is just an additional activity for farmers. The majority of beekeepers are like that. Like there are very few of them who are pure professionals. But one of the co-authors of the paper, so in her family, her uncle is actually a professional beekeeper, one of the oldest in Slovenia. So he uses the different technique, which is shown on the in the right part of the figure. So actually, as you see, he does it like how to say more. He takes more care about the beehives, and because he has really a lot of them, they are more like how to say located in groups, as you can see here. But some other people have them dispersed throughout the woods. And that's the most common case. Although they are done the same way like in these types of boxes. And that's where our solution primarily targets application. Because in both these cases, you could only have a single, let's say, sensor with multi-channel AD, and so you could do it like in a different way. So what we used was Arduino Due microcontroller and the Dragino LoRa shield. This is like the photo we could taken in the lab. So this is the schematical representation. So we used it to measure temperature. So you can see how this is done like in 300 hours, means more than 10 days. So you can see all the variations during the day and night. So temperature was just used for a proof of concept, although it's typically a variable that gets measured in beekeeping. It's important for various purposes, but at the end I will tell you more about what we actually really want to achieve, and to a certain extent we already did. But we need the same concepts of measuring some variable profile over various time plus some actuator. So this solution proved to be feasible. What we really try to do is like serious journal paper in this area is that the problem with the bees is, at least in Europe, is that they often get attacked by a certain parasite called Varroa destructor. So in order to fight it, there is a way to do it. So when the larvae are hatched, you can put certain evaporator in a beehive that makes how to say air with a kind of some low concentrated acid environment. The problem is that if this concentration is too low, you don't kill the larva. Of course, bees also don't like to be in acidic environment, so you don't want it to be too high. Plus, if it's like really high, this acid also influences the taste of the honey. So now the problem is that this concentration is highly dependent on temperature and humidity of air. Plus, you know, the bees, because of this acid, try to fight it with, like trying to ventilate the hive, beehive, in order to get rid of it. And then, you never know. First of all, depends on the number of the bees in the colony in the hive, and also how active they are. And, the only way is to measure this concentration. The problem is that people do that, but only for research purposes, because the equipment is far too expensive for beekeepers. So we developed an actuator which measures the quantity of the acid that evaporates. And also we do a control of this process, and all this information then is transferred via the setup that I have shown in this paper, also to the data collection center. Plus we do other parameters, let's say temperature, humidity, and you can monitor to a certain extent the health of the bee colony. We also try to do, but here the problem is power consumption, to do analysis based on acoustic emission. But in this case, it's difficult. First of all, it's more power consuming operation, and it has to be done on some longer time frame in order to get the fast Fourier transform correctly. So this is what we are actually also active in. So yeah, basically with this I would end the presentation part, and now I'm open to any questions.